Welcome to Lab Rats. Last time, we explored all the different colors of light that you can see. But there is actually way more light that you can't see. Remember, light is made up of a bunch of waves, and each color is a different size. They each have their own wavelength.
Dude!
Humans don't actually have the best eyes in the animal kingdom. We can see from violet, 380 nanometers, to red, 700 nanometers. Other animals can see well beyond that. From octopus to mantis shrimp, even bumblebees. Let's take a look at the complete electromagnetic spectrum. Humans can only see in this tiny little window we call visible light. Everything else is completely invisible. Past the violet color is ultraviolet. Waves that are even shorter but have more energy, which can actually cause breakdown of our DNA. The highest energy electromagnetic waves are gamma rays. You want to stay away from those. Let's go back down the spectrum. Past red is infrared, and that actually makes us feel warm. If you go all the way down, you'll find radio waves. We don't just use those to send music to our cars. If you're using Bluetooth or using your cell phone to access the internet, you're using radio waves. Electromagnetic waves are a form of energy, and depending on their size, their wavelength, they will interact with matter in different ways. For example, X-rays, they will pass right through our skin, but allow us to see our skeleton. Let's check out this part of the spectrum. Does that look familiar? We use microwaves to heat up our food very quickly. But how does that work? Humans have found the exact wavelength of light that interacts with water. It forces the water to spin. And as it spins, it's hitting all the food particles around it, which causes it to heat up. Let's do an experiment with the microwave. All you're gonna need is a marshmallow, 2 chocolate bars, a ruler, and a bar of soap. Ivory soap works the best. Use a plate for easy cleaning. Put your marshmallow in the center of your microwave. You only need to do this for about 20 seconds. Remember, microwaves apply a lot of energy that can heat up your food to the point where if you touch it, you will get burned. So be safe with these experiments. Look how big that marshmallow got. For this experiment with your chocolate bars, you need to make sure that your microwave does not rotate your chocolate bars while cooking. When you rotate the chocolate bars, you are heating them more evenly. But that's not your goal here. What you want to do is make sure that the waves are hitting the chocolate at the same point over and over and over again. So you can see those points at which it is melting. Your goal here is you want to melt the chocolate bars, but not fully. You want to get it to the point where it just barely starts to melt. So let's try it. Put these in right in the middle and I'm going to put it on for 20 seconds. Now what you're going to do, you want to take it out and mark the 2 points that are completely melted. The most melted points are the peaks of the wave that is your microwave. And you want to measure the distance between them. I have here 10 centimeters. To calculate the speed of light using your microwave and these chocolate bars, ask your parents for help. First thing you want to do is look at your microwave and find the sticker that shows you the microwave's frequency. My microwave says 2,450 megahertz. You guys have a pen back there? To calculate, what you're going to do is take the distance that you found of your 2 melted points of your chocolate. You're going to multiply that by 2, because the 2 melted points is actually half of your wavelength. And then you're going to multiply it by the frequency. Now the M, the megahertz, that means 10 to the 6. That means there's 6 zeros behind this number. Use your calculator, use your parents' help to multiply this number with 6 zeros times the distance between your 2 melted points. And that will be roughly the speed of light. Remember, use your plate for easy cleaning. It might not look like much to start, but pretty soon you should see it start to rapidly expand. Oh, there it goes. There's small trapped air inside of these bars of soap, and when you heat them up, they rapidly expand. You want to let it cool a little bit before you touch it, because remember, microwaves apply a lot of energy and can be very hot. But it does feel a little fluffy like a cloud. I hope you enjoyed exploring the rest of the electromagnetic spectrum today. There is a lot more to this magical world than you can actually see. So use and trust your other senses, because they might help you discover something new about the world that's all around you. Happy sciencing!